Hello, I'm Omkar. I'm going to explain the applications of rapid prototyping in automobile industry. So, a little bit introduction about what is rapid prototyping. Rapid prototyping is fabrication of scaled models of or physical parts or assemblies using 3D CAD data directly. So, in the modeling or in 3D CAD file, we can directly import it into the rapid prototyping machine and directly manufacturing of the object is done. It was introduced in late 1980s and was used to produce models and prototype parts. So initially it was only used to indicate what the final part or the physical product is going to look alike, and it was just to get the idea about the geometry or the applications of the products. Rapid prototyping is an additive manufacturing process in place of the traditional subtractive processes, just like turning, milling, drilling, etc. All such processes remove material from the actual part. Otherwise, on the other hand, rapid prototyping is an additive manufacturing in which the material is added layer by layer to produce the product. So, rapid prototyping has a wide range of applications today. So, in automotive industry, design, development, manufacturing, and marketing of motor vehicles is done. One of the world's most important economic sectors by revenue. So, rapid prototyping has been used extensively for automobile, aerospace, aeronautics, railway, and electronics applications. It plays key role in maintaining the competitive advantages in any industry, which is a part of economic world today. So, in today's world, production of dashboards and cooling vents in most of the cars has already been is already being made using rapid prototyping. Additive manufacturing based production of a greater number of components is possible in future with the advancements in the additive manufacturing technologies. So basically, in automotive industry, these are the areas of applications of rapid prototyping. Firstly, for design verification, low-cost prototypes of products which are large, complex, and costly for visualization and testing procedures. So for such products, the design verification can be done using scaled models which are produced by rapid prototyping. Volkswagen has utilized LOM method, that is a laminated object manufacturing method, to to produce a gearbox, which was used for design verification purposes. So basically, the design was produced using five parts. So, and later these five parts were joined together to get the overall idea of the design. Second one is prototyping and testing. This is the most commonly used area of application for rapid prototyping. This is nothing but testing of samples and making prototypes of the actual products and use them to give idea or visualization idea of the actual product to the other customers or other management, etc., and also do some mechanical or environmental testing or any other sort of testing we can do on these products. Third one is A rank. It is nothing but some basic parts which are used in automobiles or cars. Then next is visuals or show vehicles, we can say. The visual is nothing but RP methods can be used to replicate or introduce new designs of cars or any accessories used in automotive industry. Study them further and discuss with the management or customers. So this is nothing but actual 3D scale product, which can be used for visualization of the product. Then next is interior bugs, that is some parts which are used in interior of car. So interior parts, can include dash, console, back of the chairs, then buttons, cup holders, mirror housings, etc. So these parts which are used in interior of the car. So these actually have very complex shapes. So in one of the major advantages of rapid prototyping is it has no restriction over the complexity. So it is better to produce such products by rapid prototyping than other traditional methods. So next one is underhood parts. Underhood parts are the parts which are inside the structure of vehicle or under the bonnet, we can say. So these can include grill covers, emblems, so air filter housings, then radiator brackets, battery enclosures, etc. Such products are can be manufactured easily using rapid prototyping. Next is integrated components. Some components or parts can directly be manufactured using the methods and used in assembly of automobiles. So such components of the some automobiles can be directly manufactured using rapid prototyping. Such components include A pillars or B, C, D pillars, which are nothing but the pillars between the doors of the automobile. So these can be manufactured using RP methods, or other cowls, spoilers, tail light covers, then trunk trim, interior and exterior trim. Such parts can be directly manufactured using RP methods. Next is mask customization. These are the parts or contours which are difficult to process using traditional machining methods. So these are usually modification and customization, which can be easily obtained using RP methods. So these are some of the major components which can be manufactured using RP methods. Which, as I already mentioned before, these are dashboards, consoles, air vents, door panels, grills, then A pillar, B pillars, then gaskets and seals, then emblems, trunk lids, etc. This gives us a basic idea about what are the possibilities of application of RPA methods to produce uh, these products in the various areas of automobile. So these includes air vents, cowls, battery enclosures. These are the underhood parts which we can see, such as battery enclosures, air induction components, etc. Then some parts we can see in the interior, such as back of chairs, cup holders, then buttons, knobs, body panels, etc. Then other than that, we can see grill covers, radiator brackets, then exterior trim, etc. So these are the technologies which are majorly used in automotive industry for production of various products. These include the technologies are cast urethanes, FDM, that is fluid deposition modeling, SLM, then stereolithography, etc. Then these are the major materials which are used in automotive industry, which include production thermoplastics, then nylon, then advanced formula polymers. These are the polymers which are used in stereolithography, then composite materials and metals and alloys, etc. So now we will go over some major areas of applications which are possible in automotive industry. First one is exterior trim, that is some parts which are used in exterior of the automobile. These include bumpers, windbreakers, etc. So in bumpers, usually SLS is used, selective laser sintering. Then material used is usually the polymers. Then next is windbreakers, which also SLS and polymers are used. Windbreakers are nothing but spoilers, we can say. Spoilers which are used in front and rear of the automobile. The next area is fluid handling, in which pumps, valves used in the automobile, or various pumps are used in automobile. So parts of those which can be manufactured using RP methods. The method usually used for pumps is SLM, that is selective laser melting, and material usually used is aluminum alloy. And for valves which are used in pumps or any other situation in automobile, it is manufactured using SLM and electron beam melting. Then material usually used is aluminum alloys and magnesium alloys. So next important area is manufacturing processes. So usually prototyping of various parts or design is done using FDM or SLS. Then polymers and metals can be used. Then another part is customized tooling, or we can say rapid tooling. This is the tooling which is specifically manufactured for specific applications of automobile industry. So if you want to specifically manufacture one part of the automobile, then the tooling required for that specific part can be manufactured using RPA methods. Usually these methods include FDM, inkjet, selective laser melting, and materials are hot work steels and metals, which are obvious. So as it is the tool manufacturing, so we need a harder material. Then another is investment cast products. The method usually used is stereolithography, SLS. Materials used are polymers and wax. On the right, we can see the assembly of rear wiper system, which is used in automobile. Then next area is design verification. As I have previously said, method is usually used is LOM, or any other method can be used, and material for LOM, which is plastic, metal sheets, etc. Another area is exhaust and emissions. So cooling vents or exhaust pipes, which can these can be manufactured using RP methods. Method is usually SLS or selective laser melting, and material is polyamide powder, aluminum alloys. So this is another overview of applications of RP in automobile industry, which include various areas such as interior, exterior trim, fluid handling, manufacturing processes, exhaust and emissions, interior and seating, wheels, tires, suspension, electronics, OEM components, frame, body, doors, powertrain, drivetrain, which are underhood products. So this some applications in each area are given, and technology used in for those applications is given, and material which is used usually is also given. So this gives us complete overview of automotive applications of RP processes. So we'll go over some case studies. So this is RB, which is model automobile which is completely manufactured using RP methods. Uh, Most of the products are manufactured by RP methods, not 100%, but still we can say up to 60 to 70% products are manufactured using RP methods. First version of RB was introduced in 2011. So external frame composed of 20 separate panels built through RP processing. Usual method was FDM. Then next step was they partnered with Major Rapid's prototyping service bureau and used a design and simulation software to build the build the RB. Next is which is undergoing project, that is RB2. So CAD modeling of that began in 2013. 3D print of interiors and addition to external body is being done in RB2. More parts, that is 40 to 50 major parts and interior parts, will be 3D printed in this version, and greater complexity of part which cannot be produced through traditional manufacturing method, which is possible using RP methods. This is second case study. This is the first 3D printed supercar, we can say, which is named as Blade. It is made by Divergent Micro Factories. So the major advantage of this car is superior weight reduction. It has 1800 pounds of curb weight. So 1800 pounds is very much less. That is around, even our other normal car, that is Maruti 800, it has curb weight of 1833 pounds. So you can see the it this supercar, that means it is a performance car which is already by lesser by weight than our normal regular car. It goes 0 to 100 mph in just 2.2 seconds. So you can see the comparison between those. Majorly, the weight reduction is achieved using RP processing, as well as the most of the parts which are manufactured, the material used is carbon fibers and carbon nanotubes. So it is one of the strongest materials available. So that is why we get the rigidity as well as the performance out of this car. So now we will see one video about the Blade, that is first 3D printed car, how its chassis is manufactured and assembled. This was the chassis, which were most of the parts were built from carbon nanotubes and carbon fibers and produced using RP processing, and these were assembled together. As the volume of the product, it is somewhat lesser possibility in RP processing. So many products are made and then they are assembled together. So conclusion is, rapid prototyping has become one of the recent and cutting-edge technologies in automobile sector. While additive manufacturing will not become the only manufacturing technique in future, it will nevertheless play an important role in shaping the global automotive landscape. Considering the breadth of capabilities unlocked by additive manufacturing, leaders of automobile companies should consider taking advantage of AM technologies to stay ahead of the competition. Thank you.